Hello, UM6P community. How are we doing this morning? Welcome. Let's get some energy in this room. We've got a full house this morning, ladies and gentlemen. We've got the grads, the undergrads, the professors, of course, the PhD students, the UM6P staff. We've got guests from all over the world. Thank you all for investing your time. If you're watching us on YouTube, hello to you as well. Welcome, everybody, to this fourth edition of Science Week, brought to you by UM6P. My name is Manal Bernoussi. I'm a student of this wonderful university, and it is my privilege to be your host, your MC, your friend over the next 5 days, making sure you get all the information you need to make this experience memorable. We're going to spend the next 5 days together celebrating science. The African Sustainable Agriculture Research Institute, which is the UM6P branch in Laayoune, funded by the Fouad Foundation, is celebrating with us. UM6P in Rabat is celebrating with us. UM6P France, the latest branch that has been launched a couple of weeks ago in Paris, is also celebrating with us. The whole community is gathered here around science for one whole week. We are so unbelievably privileged to have over 50 globally renowned researchers. These are superstars in the field of science, so don't miss 1 minute. If you've got something on the calendar, just cancel it, okay? Call them, tell them I'm busy spending my time with some of the brightest minds on this planet. I'll just see you later. Okay, a couple of housekeeping principles, and then we're gonna get the day started. Number one, dedicate the time. You're here, so be here. Put out your phone, be 100% present for this very unique opportunity, and take advantage of this. Second, play full out. Ask questions, interact with the speakers. Again, this has really been designed for you to make the most out of it. Plus, there are some really cool incentives to get you play full out, so play full out. Now, without further ado, and to officially kickstart this fourth edition of Science Week, please join me in welcoming through the stage President of UM6P, Hicham El Habti.
Assalamu alaikum. Bonjour. Good morning. Excellencies, Governor, Mr. Governor, distinguished guests, dear faculty, students, and colleagues, ladies and gentlemen. I'm personally proud and honored to host you today for the first edition of UM6P Science Week. This is a wonderful journey that we have started a few years ago as a tentative to explore science that became today a rendezvous twice a year where scientists, students, and general public interact under the auspices of our university. To say that Science Week is an exceptional event would be an understatement. In 3 years, it has become a central event for our campuses. It's a key moment in the life of the UM6P. In fact, one of the first virtues of this week is to bring together the joint forces of the UM6P in a week-long space-time. On this occasion, researchers, academics, and students can observe and admire other members of the UM6P family, whatever their discipline, from the hard science, such as physics or biotechnology, to the humanities, such as political science or management. But above all, is the only time for a whole week when all the campuses of Laayoune, Rabat, Ben Guerir, and now even Paris connect as a single campus. It's a kind of a giant team building on the entire university scale. But beyond the internal self-recognition exercise, which consists in being aware of what others are doing within the UM6P ecosystem, it's an exercise in opening up to others' work, other international researchers' teams. It's a way of gaining external recognition at the same time getting to know the outside world. It's about bringing in outside researchers with whom we already work and those with whom we could or would like to work. This year's guests are not only all major internationally recognized scientists who happen to publish in the world's leading journals, award-winning scientists, as you will see if you live through the program, but they are also personally committed women and men who are eager to take part in the great adventure of transitions, which is the great human adventure of the 21st century. It is important to remember, therefore, that this is not just another academic conference for researchers in a vacuum, nor is it simply a giant popular science conference. Rather, it's a beacon to keep us on course, to light the way for our researchers, students, teachers, and also the general public. We would also like it to be a beacon that, beyond the UM6P, can light up the African horizon, and why not the world horizon. We have to be ambitious, and we can only be ambitious if we want to be able to change direction to meet the new challenges facing us as human beings. Being able to respond to the new challenges awaiting us, such as climate change, is the first meaning of the word transition that comes to mind, and it's the theme we've chosen this year. This week, dear friends, will be truly exceptional by virtue of this theme of transitions, not transition, but transitions in all fields of science. This year's theme, transition, is crucial for the world in general, but also for the UM6P in particular, for a multitude of reasons. Number one, because the transitions are UM6P's DNA, its raison d'être. Our university is founded on research, as we all know, but on the search for a new way of approaching the world, of managing our relationship with the environment, of overcoming the challenges of climate, water, food, social issues, and so on. It was therefore necessary for us to raise this theme of transitions loud and clear at some point. We have now done so with the Science Week. Number two, it's a crucial theme because it calls for even greater collaboration between laboratories, centers, and departments, because you can't make a transition on your own. Number three, that's why this Science Week was organized in close synergy with all forces existing within the UM6P across all campuses. All centers took part in a spirit of scientific camaraderie and shared adventures. That's why, over this past year, the people behind this team have been working intensively on this synergy within the departments, going out to meet department heads, researchers, and doctoral students, talking to them, asking them to mobilize their networks, and also asking them how their discipline could be represented. But we've gone one step further this year, since it's the students themselves, with priority given to doctoral student junior researchers and postdoctoral students who will chair the sessions and act as rapporteurs for all conferences and workshops. They will be the first to be involved, and they will open the door for the others, for all the others in the room, to participate more intensively and more freely. It will also be an experiment in what is known as reverse pedagogy. In other words, the speaker's initial talk will be very short, not so as not to let them speak or have them speak superficially, but on the contrary, so that the in-depth discussion can then take place in synergy with the room under the impetus of the doctoral students who have already been familiarizing themselves for several weeks with the speaker's work. We tried this out in October, and it works marvelously. Finally, this week will be a real scientific laboratory with a scientific product. It won't be an ephemeral event, but a work in progress that will culminate in the production of the white paper of transitions, made up of the reports of the rapporteur, not like in typical symposium, rapporteurs who are, as I said before, PhD students from the UM6P. Last but not least, UM6P has launched recently the Institute of Advanced Studies, which is a unique structure in the Arab world and that has transitions and one of its unifying themes as it hosts the chair of transitions. The IIS mission is to offer the adequate platform to host scientists from all around the world who would like to spend time within UM6P's ecosystem, interacting with students and initiating projects with added value to the community. In conclusion, I would like to take this opportunity to thank all the colleagues who have contributed to the organization of this edition, namely the Scientific Committee, the Communication and Events team, and all contributors who have worked hard to make your journey an enjoyable one. Thank you all, and let the 4th edition of the Science Week begins. Thank you.
Thank you. Thank you, President El Habti, for making this wonderful opportunity available for us all. And a big thank you indeed to the organizing committee, Fouad Laroui, Saâd Tazi, Raphaël Liogier, Reda Ben Kiran, and Narjis Lamrani, for their hard work and dedication in making this event possible. Yes, thank you. Let's give them a huge round of applause. Your efforts truly make a difference, and we are incredibly grateful for everything you've done. Now, it is time for us to hear from someone who needs no introduction. He has initiated Science Week, and we're so grateful that he did. He is an esteemed economist, an accomplished writer, and a published author. His work explores contemporary themes such as identity and cultural dialogue. He has been honored with many awards, including the Prix Albert Camus and Prix Goncourt de la Nouvelle. Please give a very warm welcome to Mr. Fouad Laroui.
Thank you, Manal. Mr. President, Mr. Governor, dear friend, dear guests, esteemed colleagues, dear student, not used to waking up that early, ladies and gentlemen. Well, indeed, I'm waiting for my presentation. It should start any moment, I hope. The question I will try to answer is why? Why do we have a Science Week? Yes, it works. Miracle. Why a Science Week? Well, we only have to go back to what is the mission of UM6P. UM6P is about scientific research, excellence in research, excellence in teaching, dissemination of knowledge. I think Mr. President will agree with me that these are the three most important missions of UM6P. Scientific research, it means that we have to fight for science. Yesterday, I was talking to my good friend, Raphaël Liogier, who will be here couple of something like 20 minutes, and I asked him, what is that painting there by Vermeer, Johannes Vermeer de Delft? And Liogier said to me, is Vermeer's astrologer. And I got angry because in the last 20 years, every time I ask someone, what is this painting? They always tell me, oh, it's Vermeer astrologer. It is not astrologer, it's astronomer. Astronomy is science. Astrology is ballooning, is BS. We have always to remember that. Please, Raphaël, from now on, this is Vermeer astronome, not astrologue, all right? Scientific research. We have to defend science. Written there, défense et illustration. The S is not an error, it's French. Joachim du Bellay wrote Défense et illustration de la langue française, 16th century, and we should always write Défense et illustration of science, because science is in danger every day. Superstition, ignorance are rife. You know how many people believe that the earth is flat? Guess something, Professor Dennett, something like 27% people in America, some such thing. Actually even met, personally, people with a university degree who believe that the earth is flat. We have to fight. You know now, we have facts, and since a couple of years we have even what they call alternative facts. If you look at the pictures, you see all these people had problems, scientists, great scientists, they all had problems with bigotry, with ignorance. Look at Ibn al-Haytham, one of the greatest scientists ever. He had a problem with Al-Hakam, who was a completely mad ruler. Obviously, Galileo, we all know what happens to him with the church at the time. In black and white, Giordano Bruno burned alive in the year 1600 by the church because he believed in the system of Copernicus. Burned alive. Never forget Giordano Bruno. And by the way, the Copernicus system had already been found by someone called Nasruddin Tusi hundreds of years before, but it's another story. And obviously Darwin had a lot of problem with the church, and still today has a lot of problem with bigotry and ignorance. We have to fight for science. Excellence in research, excellence in teaching. It's not just a slogan. We have to show it. So during Science Week, every department of the university is concerned. Dissemination of knowledge is the duty of every scientist. We should not be like Newton. This is not Newton, this is Louis de Funès, but Newton is there. As you know, Newton is maybe the greatest scientist ever, but he had a very, very bad habit. He didn't publish his result. So from time to time, when somebody like Leibniz, for instance, said, oh, I discovered something fantastic, Newton said, I discovered it 25 years ago. It's here in my drawers. No, we should not be like Newton, a genius, but somebody who didn't want to disseminate knowledge. We should do that. Now, people ask, what's your motto, Science Week? Well, let's look at all these people. What do they have in common? Aristotle, Ibn al-Haytham, Galileo, Darwin, Marie Curie, Einstein. What do they have in common? They were all at the frontiers of science. Well, it's a goal in itself. Science is never wrong. Scientific knowledge is never wrong. It's always okay to know things. Obviously, some technical uses of science can be questionable. If you look at Einstein, discovering E equals mc squared is great, is wonderful. There's nothing wrong with it, all right? I say this because sometimes people say, science can be dangerous. No, science, knowledge is never dangerous. It's what you do with it that can be dangerous. Dr. Rita Colwell wrote a book titled or mistitled Science as the Frontier and the Frontiers Within Science. No, there should be no frontiers within science. Should be frontiers, maybe ethical, moral, the uses of science. So it's a goal in itself. At the frontier of science, it's our motto. It means also that we are the cutting edge of technology. We aim to create new industries. We want to contribute to a robust and healthy society. That's another meaning, to be at the frontier of science. To be at the frontier of science means also another thing. You have to cross traditional disciplinary boundaries. If you are at the frontier, you have to cross boundaries. You have to remove disciplinary walls. There are silos from somewhere in Texas. That's the best picture I could find to illustrate this idea. Remove silos, remove disciplinary walls. think outside the box. That's also what it means to be at the frontiers of science. At the frontier of science, we can have disagreement, debate, arguments, ethical and philosophical questions. Science sans conscience n'est que ruine de l'âme, science without conscience, or ruin of the soul. That's what the great humanist Rabelais said in the 16th century. It's also part of our motto, obviously. Now, how does it work? Well, every department should organize during Science Week some high-level conference, interesting scientific questions that they ask themselves, some renowned scientists. Every department exhibits its realization, its achievements, its production. It's time to brag. It's okay to brag. If you have done something great, you have the right to brag. And every time we choose a year in advance a theme. The first year we chose as theme when science spoke Arabic, because most people didn't know that there have been three great movements in the history of thinking, of philosophy, of science, let's say. The Greeks, the Arabs, and then Europe since the golden age of 17th century with Galileo, Huygens, Descartes, and Newton. We chose transhumanism in 2022, complexity last year, transition this year. Actually, the theme I'd proposed was origin, evolution, transition, but my good friends, Liogier and Saâd Tazi, they told me, no, it's too long. Let's just say transition. It sums up the whole thing. Students and staff can organize readings, art exhibition, plays, music events. Before I finish, I would like to relate another discussion I had with my esteemed friend, Virginia Chaitin, who is one of the residents here in the Institute of Advanced Studies that we created this year. I was, again, ranting against astrology. I was saying, astrology, this is bullshit. Sorry. And then Virginia says, no, please, Fouad, don't say that, don't say that, don't say that. So I had a discussion with Virginia. It appears that Virginia is a big fan of the philosopher Paul Feyerabend, philosopher of science. And obviously Feyerabend was the guy who wrote this book called Against Method, and whose idea was everything goes. If you are doing research, don't be tied by one scientific method. Try them all, try anything. So every time I say something about astrology, Virginia say, no, Fouad, don't say that. We will have this discussion this Thursday because we have a whole day devoted to the centenary of Paul Feyerabend. He was born in 1924. So we will have the whole day. We'll get into a big fight with Virginia and myself. At the end of the day, we'll be friends again. If you want to see a ramble in the jungle, come on Thursday to the Feyerabend centenary. Now, I'll finish by saying, let's get started. Thank you very much.
Thank you. Thank you so much, Dr. Laroui, for this opening session. Thank you for reconnecting us with what it means to be at the frontier of science, and also reminding us the topics of the previous editions, which are definitely part of the legacy now. I'd like us now, ladies and gentlemen, to welcome on stage someone who's really been pivotal in bringing all of this together since day one. He's been doing a tremendous job with all the organizing committee. He'll tell us more about the program and also some of the cool incentives that put in place for you to come every day, to spread the word, and tell all your friends also to join. I'd like us to please join forces and welcome Mr. Saâd Tazi. Let's give it up for Saâd Tazi. Thank you.
Assalamu alaikum, good morning. I would like to share some personal things with you just in a second. The first time I came to UM6P, I was quite impressed by the buildings, the staff, and most of all you, our students. When I went the first time into the old auditorium, I found it incredible. And today, we're here in this one, which is even more incredible. This is how life is. You think that you have reached the top, and then you find out that there's more room, then you can go higher. This is my wish for all of you. And Science Week is meant for this, a tool for you. Science Week is a teamwork. More than 100 people have been working behind the scenes to bring this to you. And it took us a lot of months, a lot of thinking, a lot of efforts. And I would like to thank everybody on your behalf, if you don't mind. This week, you'll have the opportunity to listen to brilliant people. Thanks to Campus Plus and to its founder, Khalid Baba, you can book all the sessions you want to attend. For those of you who are not familiar with the app, here's a short presentation. Thank you. So thank you, Khalid, for your great work. There are 6 conferences, one every day, except today when you will have 2 for the same price. Please be here and take advantage of their content. For the rest of the week, and I remind you that Science Week attendance is mandatory, you can choose between different tracks. Since we are on a dense and tight schedule, please try to be on time, because if we keep starting late, we will skip some good messages, and please be on time. The good news is that every time you attend a session, you take a photo and upload it, you visit a booth and you talk to people within the booth, you earn points. At the end of the week, the highest point holders will get an invitation for 2 at the great 5th SHBM restaurant that everyone is talking about, from Marrakech to Casablanca and Rabat and beyond the borders. At the end of each session, you'll be able to book a small group meeting or one-to-one meeting with the speakers in order to pursue the dialogue with them. You can do so with your Campus Plus account. Please talk to each other, engage with our guests, create your network, and let's make out of this week a milestone on your journey. I wish you a great 4th edition of the Science Week.
Thank you so much, Saâd. Thank you for detailing all of this for us. This is a really fun challenge, everyone. Have you heard about all these incentives? Every day we'll be able to see who are the top students that really played full out, who are the students that attended the most sessions, that have been interacting the most, and they'll get the amazing experience at the gastronomic restaurant. Believe me, I've been there. You do not want to miss it. Okay, now we're fully diving into our theme of the year, transitions. The world is undergoing significant transitions, including energy, agriculture, climate, digital, financial, societal, moral, to name just a few. And there is truly no one better equipped to guide us through these topics and changes than our next esteemed speaker. He is very well known in the fields of sociology, philosophy, and cultural studies. He has published numerous books and articles contributing to academic and public debates. He is the scientific director of the Institute for Advanced Studies and holder of the Transitions Chair at UM6P. Please join me in welcoming to the stage Professor Raphaël Liogier.
I I'd like first to thank my very good friend Fouad Laroui to have given me the opportunity to start well in this day, in this great day, because I think, in fact, the very difference between astrology and astronomy, it's a very simple difference. It's that an astrologist always thinks that his science, because he thinks it is his science, is right. But an astronomist, he doesn't think that his science is always right. So in a way, we could say that Fouad Laroui was a bit of an astrologist, in the way he said that science is always right. But I don't think science is always right. It's contradictory in itself, because it's a critical mind that is important. And part of the methodology of science is actually to be critical about itself. Otherwise, it will fall into some kind of dogmatism. Anyway, let's start, really. I will say that, for me, the UM6P, a personal point of view, but not only a personal point of view, is a dream. It's a dream of a company, a very successful company, OCP, and a dream that actually come true, and all the dreams don't come true. But this dream has come true. And in fact, it could be one of the first definitions that we can have of a transition. Because a transition is not really only an evolution. An evolution is something more linear, you know. It's not also a break. A transition is when you go beyond a state that was there before. And it's like if this university was dreaming something to go beyond, and actually the product of this going beyond is the university itself. So after having talked about this first definition, like to enter into the definition of what is a transition, going beyond, I will say that usually when we talk about transition, we mean two things. We mean first external transitions, like the environment, the weather, climate change, and all these things that are surrounding us. Environment, in one word. But we think about something else. We think about inner, internal, social, human transition. How, with our own transition, are we going to face the transition that are imposed to us from the outside world? So the real problematic, the real question is actually that. So you see, transition is not one unique transition like sometimes you hear in the media, like the transition. No, it's transitions everywhere. But what I'm saying now, it doesn't mean that because it's plural, it doesn't mean that it's not a simple, specific concept, and I'm going to enter into that to say, what is this concept? When I'm saying that it's going beyond, we could ask, but going beyond what exactly? In fact, it's going beyond a point, what we could call a point of balance, an equilibrium, a certain equilibrium. So now, we could say that the circumstances that we are living in, climate, society, is a certain kind of equilibrium. And when we say there is a problem of transition, we mean this equilibrium could break to give birth to something else. And are we going to be here if there is something else, another equilibrium, or not? But on a more fundamental level, the question of transition is scientific. I will say it's even the real challenge, scientific challenge of our time in every field in science. Because everything that we know, everything that is around us, everything that is in us is actually here because a certain point of balance. It's even more than that. Everything is a point of balance When we talk about an atom, we know now that an atom is not like the atom, the image we had a long time ago in the antiquity, like Democritus or Epicure will think, like something precise. No, an atom is a point of balance. The Earth is a point of balance. An organism is a point of balance. So, when I'm saying it's a mystery, it is that now what we call, up to now, what we call science are actually the rules that we were able to find in a certain point of balance. Atoms or something else like society for sociologists or something. But what we don't understand is what is really, but really actually happening when from one point of balance, something else is emerging. People, and sometimes scientists, to reassure themselves, to make them think they know what they are doing and what they are saying, they said, like the other year, complexity. But that doesn't solve the problem. We actually don't know what is happening from one state to the other state. There are many hypotheses. And when in science you have many hypotheses, that means you don't know yet. So I think this is the real mystery of science now, and we give other names. For instance, we give like emergent state. Something is emerging. Something is actually happening. Not only happening like that, I mean, it's a new stability, new matter that is created, that is there. You know? We don't know, we know it's happening because the pressure, because a certain intensity, because the quantity, because what we call complexity, but we don't know how a certain quantity, for instance, a quantity of neural transmission, will become what we call awareness, for instance. You know? So how, and it will be another definition if we go a little bit deeper of what is transition, is how a quantity becomes a quality, a new quality. How does that work? In all the fields, in all the different fields. For instance, if we start with the first one, we will say the first emergent state, so the first transition, is actually what we call the Big Bang. What we call the Big Bang is an emergent state. Something that we don't know is, so we sometimes call it nothingness. From this thing emerge a thing that we call, step by step, what we call the universe. But now if we do the other way around, if we do it the other way around, if we focus the other way around, we see in quantum physics, in microphysics now, if we talk about the wave function collapse, like the fact that there is an outside interaction, that means that there is an outside interaction, right away, there is something new that is happening. Something new that is not the same, that has different laws, that we can study. And we know the laws of this something new, but we don't know how we went beyond what was there first. So we don't know the transition, what went beyond. So you see, transition is not evolution, it's not a break, it's both. And we know that everywhere in nature, it is like that. Now if we talk about nuclear fission, it's the same. It's like a very heavy atom with radioactivity, and at one point, it breaks, and it becomes something else. Or nuclear fusion is even more mysterious. And we will have a session on cold nuclear fusion, which is even more mysterious than nuclear fusion as a whole, because what we imagine up to now is with thermic reaction to produce nuclear fusion with laser, or in France in ITER, which is, by the way, in my knowledge, one of the most expensive research programs in all the history of humanity, ITER, to find fusion. Because if we find the key for fusion, and we will talk extensively about that on our last day with Random Mill and Gregory Chaitin. We solved so many problems. We solved the problem of energy, we solved the problems, scarcity of what we need every day. So, you see, atoms, and also from atoms to molecules, the transition. What is the transition? From macromolecules to cell, inert to living organism, and what we call in physics phase transition, with the same formula, ice, and it becomes liquid, water, or it becomes a gas. We think we know, but in fact, a proof, if I can say that we don't really know, is that the only way we have to try to describe it, to understand it, is statistical. It's statistics. There are statistics. So also, how can we understand when we have neural pathwork, neural networks, and it becomes awareness, and when it is individual awareness, how do we assert the transition from individual awareness to collective awareness? How does that work? How many individuals do we need to make a society that will be somehow aware of itself on a certain level? We don't know. There is this interesting word in Greek that is the word cosmic. I don't know if you know, but etymologically cosmic, that's the same etymology of cosmetic. So that means that, and it means the hair. Because the Greek, they were comparing the universe like a face that has a certain aesthetic, a certain harmony, but you don't know how many hair you need to make this harmony being what it is. So you also have negative transition. To show you that in every field, it's really becoming the point of study. That's really becoming the enigma of science now, everywhere. When we are talking about cancer, in biotechnology, in medicine, it's about that we are actually talking. How, like a regular cell of our body, is transiting to become a tumor. And at first, a benign tumor. But how a benign tumor transits to become a malignant tumor? Some tumors, they never transit. And so we have hypotheses, but always statistical. Like when there is glucose, when that is happening, when there is this kind of interaction, but we really don't know what is the reality, what is the real cause of this point, this balance, this transition, and how it becomes a malignant tumor. It could be just a malignant tumor, but not being metastasis. It's another transition, and why? How does that work? We also have transition, as my very good friend Gregory knows very well, because he's a specialist of that in a way. In mathematics, when we talk about finite numbers and infinite numbers, it's something very hard to understand, but infinite numbers, they actually have properties, and you can make calculations. And calculation that can be practical, which is really weird. And in fact, we tend to understand step by step the properties of infinite numbers and the property of finite numbers, but we don't understand well how we go from finite numbers to infinite numbers. So everywhere we have that. And now, for something that is obviously evolution, that was, so to say, biological evolution, I think even biological evolution, even if, because we are used to say that it's evolution, well, it will be better, more scientific to call it transition. Because we know now, thanks to the theory of punctuated equilibrium, that species, like biological species, they don't evolve like in a progressive way, like in a never-ending progressive selective way. We know that they stay where they are for thousands and tens of thousands of years because they found a certain balance. So morphologically, they stay where they are. It's not what believed Darwin, actually. They stayed. And at one point, there is a change of balance. And when there is this change of balance in a few thousands of years, of course, it's what I say, it's almost immediate on the scale of biological history, they just change. They might disappear or they might stay. So there is not something that is evolving like all the time, but there is, again, even with species, an organism, something that is keeping the same morphology because it found its balance, the mystery of the balance. It found its balance, and at one moment, there is a drop that is too much, it adapts, it changes a bit, but stays the same, and there is a complete change. So, in fact, we are asking again this question of balance now for our society, as I said, because we have to meet the challenge of maybe a change of balance. When we are talking about transition, maybe, but we have to, as I said in my first sentence when I talked about astrology and astronomy, we have to be very careful about what we believe. Even when we think we're scientists, we have to be very critical about what we think we see. It's also that science. And so what do we see? We talked, just one thing about Darwin I forgot to say, if Darwin was looking for the missing link, it's actually because he thought that it was progressive, so there was something that was missing, but nothing was missing because there wasn't a link. There was a brutal change from one species to the other, just end of this little. So when we are talking about not microscopic point of balance, the equivalent of a macroscopic point of balance, it's what we could call a sphere. A sphere. When we talk about atmosphere, stratosphere, zoosphere, like the living being, geosphere, hydrosphere, the oceans, the water, and everywhere. When we are talking about spheres, and when even people are saying atmosphere and all that, they are not talking specifically and strictly on the geometrical sphere. They are talking of actually a huge point of balance. It's that they are talking about. And even in Greek, if you say sphere, that means rebound, some kind of a dynamic that works, that is at stake, that is more or less stabilized. So when we are saying there is transition, we are saying that those spheres that work together, atmosphere with stratosphere, with zoosphere, with geosphere, this system is at stake. It's what we are saying. It's that this system is endangered because human beings are also a sphere, the way they live inside spheres. We even talk now, some people even talk now about noosphere, from the Greek nous, means the mind, because the idea is that human society, human beings, exchanging information on a global scale, and now even intensified with the internet, has created some kind of a global consciousness, a global mind that is working. And there was the first World Conference in UCB, the University of California at Berkeley, in November about noosphere, the first noosphere conference. And I'm very proud to say that the UM6P, through the Institute for Advanced Studies, of which I'm the scientific director, participated intensely to this conference, this first World Conference on the noosphere. and that maybe we will organize the second World Conference of the UM6P here in Bulgaria. So everything is made of those spheres, those points of balance on a microscopic level, scale, or on a macroscopic level, micro and macro. And the spheres works as a system. That means that they are interconnected. That's also the reason why this specific Science Week will be organized with the themes that are like the different spheres in which you can travel. This week will be some kind of a journey, an adventure from one sphere to the other. Atmosphere, energy, cold fusion, material sphere, from one and other. We will also have debate to connect those different spheres, to see what one sphere will do to the other. And in this way, maybe we will be able not to tackle, but at least to question the current challenges and to have a certain view of how works those different spheres all together. But I think one of the main problems with our current state, it is that our specific narrow sphere as human beings, our way of being, is unable to change according to the change that are actually happening in the other spheres that are around us. So we need to address that, I will say, first, in a matter of urgency. And I think one of the problem with our working in our sphere is that we lost somehow the desire, the real desire to change, because if we look at science, basically, we almost know everything we need to do to meet those challenges. Technically, I mean, we know what we need to do to avoid, to try at least, to do our best to fight against climate change. But we don't do it. And the real question, knowing that we know it, maybe not all of us, but I mean, at least the leaders and all the people, so why don't we? I think, my hypothesis is that we are unable to implement, to feed the desire, really collectively, the desire to change, because there are some kind of three limits, three problems that are like negativities. The first is the description of the phenomenon. It's always negative. From the 1980s, everything we are describing publicly is always negative. Economically, socially, on the ecological point of view, it's always negative. And it's true. Yes, there is climate change. It's becoming worse. But we're always talking and talking about that. And at the end of the day, it even became a new science as a whole that is called collapsology. People that are specialists in the fact that everything is crumbling. And the second is, what is the answer we propose, the political answer? It's to be smaller than we were before. It's called ungrowth. Try to not grow anymore. Try to not grow financially, economically, technologically. I don't believe that. Because I think what is one of the specificity of human being is that right from the start, they decide to be bigger, to be greater than what they were as a simple organism. It's one of their specificity. So if you prevent them from doing that, you frustrate them. So they feel bad. So they don't do anything. And it's what is actually happening now. And the third layer is the worst one, is the moral negativity. Guilt. Whose fault is it? Human being as a whole? The white man? The black man? people from the north, people from the south, the Chinese maybe, the Americans. I mean, at the end of the day, who cares? We need to do something. That's the difference between guilt and responsibility. Sometimes, I don't know if you mention it, even on an inter-individual way, when people feel too guilty and they express their guilt, it's a way to not act. To say, oh, I'm sorry, it's so bad, oh no. But it's not that humanity needs. Humanity needs response and action and desire to change. And real desire to change. And how do you do that? How do you introduce again the desire to, because in transition there is transcendence, it's not only a religious transcendence, it's to transcend yourself, to become more. How do we feed this desire? How can we feed this desire again? It's not a material thing. It's more of a psychic, a mental thing. So that's the reason why we decided that the first talk of this week will be about the mind, the mindset, and even about the collective mindset. How can we change, but really change, the collective mindset to be able to face, not to fake the fact that we face? Because I think now, most of the global conferences about climate change and all that, it's like if we were faking the fact that we pretend that we face something that we actually don't face, that we're not serious about. So how can we be serious about, really serious about, collectively? So I think it's really a question of changing the mindset. So that's the reason why we started with one of the greatest philosopher of living, greatest philosopher of the mind, Daniel Dennett. So that's all for now, for me. Thank you.
Thank you. Thank you so much, Professor Liogier, for a thought-provoking talk. I was taking notes backstage like crazy. So many important questions that will hopefully spark debates, discussions amongst us all. Now that we have set the stage for the full week, ladies and gentlemen, we will start indeed with one of the main transitions to focus on, which is our mindset, because we might have indeed all the technical solutions to navigate transitions, but if our mindset is not supporting, if our mind is not there, there will be no transition. Our next speaker is the world's best-known philosopher of the mind. He is one of the leading contemporary figures in evolutionary biology and cognitive science. His writings are highly influential in both academic and popular circles. And he flew in from the United States with his wife, Susan, to be with us here today. It is a unique privilege to have him with us. Let's give a very warm welcome to Professor Daniel Dennett. Welcome to you, Professor Dennett. Please take your time to join the stage. We are so grateful that you've made the trip to join us here today. We're very much looking forward. Would you like to be seated? Of course, absolutely. Please join us here at the center of the stage. We'll make sure that Team Tech, if we can make sure that this mic is on. Welcome to you, sir. Such an honor to have you. Yeah. I'll hand you the mic. We will first listen to your talk, and then, with your permission, we'll open it up to the audience. Let's give the pointer to Professor Dennett, and then we'll get this started. Thank you so much. Professor Dennett.
Okay, can you hear me? Fine. So, My talk is entitled Cogitabus Ergo Scimus. We think, therefore we know. This is, of course, a variation on a great theme from Descartes. I'm sorry, I think it would be better. I can't read my own slides, they're too far away. Maybe I should stand at the lectern and be able to see better. I really need to be. Bring the screen up. Yes,
Can we bring the screen?
sorry about that.
Team Tech, can we please bring the screen closer to the doctor?
Or maybe we're going to bring the chair. Right?
Take this one.
Yeah, bring the chair over. Yes.
Let's just take a few minutes, ladies and gentlemen, to get the setting as comfortable as possible for our esteemed professor to be able to deliver his talk. Team Tech, can you please switch on the central screen or approach the screen on the left? Thank you so much. Please bear with us in the room. We really want to make sure that the setting is right for us to listen to this wonderful talk that we're all very much looking forward to. We're talking about mindset, ladies and gentlemen. Let's give them a couple more minutes and then we'll get started. There we go.
Great.
Thank you.
Thank you. Okay, now we can get going. Descartes, cogito ergo sum. I think, therefore I am. Descartes was, of course, a great scientist. He was also very sure that he knew how science should be done. He wrote a little book called The Discourse on Method, where he told the world how to do science. And he also wrote his famous Meditations, where we get cogito ergo sum. We get it in both texts, in fact. And what I'm here to tell you is he got it wrong, majestically, wonderfully wrong. It was a great mistake that is still with us, and Newton and others could never have written and figured out what they figured out if it hadn't been for Descartes being so wonderfully wrong in the first place. Newton's Principia was in large measure a refutation of Descartes' work. My friend Keith Frankish recently tweeted, this seems to be a new way of publishing, not peer-reviewed, but sometimes wonderful bits come out, and he said, back in January, Descartes' project in the Meditations assumes epistemic individualism. His question was what he, individually, could be sure of. What if he'd started by asking what we collectively can be sure of? That is, in fact, what my talk is going to be about. Cogitamus, what do we think and what do we know? By the way, I just realized at about 2 o'clock in the morning today that today is Darwin Day. And Darwin was born on February 12th, 1809, And this is it's official in the United States. Congress, one of its few wise acts of nonpartisan agreement was to declare that February 12th is Darwin Day. So happy Darwin Day to all of you. I'm going to tell a little Darwin story. I don't normally wear a jacket at talks these days, but today I'm wearing a jacket, and you may see I have a little pin on my jacket, and it's the Darwin fish, which is a wonderful, you can get these online if you're interested. It's a Darwin fish. And it's, of course, a joke, a play on the Christian symbol of the fish and the Greek letters ichthus, from ichthyology of fish, the word for fish. And I was wearing my Darwin pin at an evolution meeting a few years ago, and the physicist Murray Gell-Mann came up to me and he said, Dan, I like your Darwin fish. Do you know the story of it? Well, I did, but he refreshed my memory. Ichthus is the world's first acronym, probably, and it stands for Jesus Christos Theon Ios Soter, Jesus Christ, God, Son, and Savior. And I said, yes, thank you, Murray. I knew that actually, but thanks for the reminder. And he said, but what I want to know, Dan, is what does DARWIN stand for? And I said, well, give me a little chance. I went off and had a cup of coffee and tried to refresh my high school Latin. There's no W in Latin, but there is the U. So I thought, what does DARUUIN stand for? And it turned out to be amazingly easy to come up with this. Delere, destroy, delete, auctorem rerum, the author of things, in order to understand the infinite universe. Destroy the author of things in order to understand the infinite universe, which I would say is as good as a motto for science as I know. So happy Darwin Day. I'm back to Descartes now. Descartes cleared the deck with his systematic skepticism. He wanted to doubt everything, systematic doubt. And what he was left with then, the only thing he could trust was just his own existence. I exist. That's it. He's stuck in a sort of solipsistic world. Could he trust any of his other ideas? That was the main theme of his meditation. And he decided that the only way he could trust his ideas is if he brought in God. He had to bring in God as a benign guarantee that his clear and distinct ideas could not be false. This is one of Descartes' great mistakes, and philosophers have written thousands and thousands of pages about why the Cartesian circle, why you can't bring in, how you can't establish God as the guarantor of your clear and distinct ideas. We might call that top-down certainty, getting your certainty from above. No, doesn't work. Just doesn't work. What about bottom-up certainty? There's no guarantee of certainty. No guarantee. But there is a path to trust your life on it, reliability. Not perfect certainty, which is what Descartes wanted, but good enough reliability to trust your life. We all make mistakes, but then others can correct us. And that is the secret of science, cogitamus, not cogito. Fermat, Pierre de Fermat, another great mathematician, another great Frenchman, and he's known today mainly outside of mathematical circles for what's called Fermat's last theorem. And let me just remind you of what it is, because it has a sort of elegant reverberation through the story of Descartes and the rest of my talk. Remember the Pythagorean theorem, that the sum of the squares of the sides is equal to the square of the hypotenuse, or as one might put it, a squared plus b squared equals c squared. It was Descartes who created the Cartesian coordinate system and the application of algebra to geometry that permitted. Now, when I was in school, I was taught that Descartes more or less found the guarantee of geometry by coming up with algebra. You could prove things with algebra. It was the other way around in that day. It was, algebra was viewed as this dubious practice of symbol manipulation, nowhere near as certain as geometry. Descartes was founding algebra on geometry, not the other way around. In today's context, you might think, what we're looking for now, one of the things we're looking for, is a similar move that could help us understand the calculations of quantum physics. We know it works, but it's still baffling in some ways how and why it works. Well, enough about geometry and algebra. You all remember the 3, 4, 5 triangle and the 5, 12, 13, where we have these perfect squares that, and the question is, how about a to the cubed plus b cubed to c cubed, or a to the 7th plus b to the 7th plus c to the 7th? Are there any natural numbers that meet this condition? That's the question that Fermat asked, and that he answered, no. There is no power higher than 2 which has any solutions. Now, he didn't actually prove his theorem. He wrote it in the margin of a book. And he said the proof, not room in the margin to write the proof. And for 350 years, mathematicians tried to solve it. Fermat's last theorem, no 3 positive integers, a, b, and c, satisfy the equation x to the n plus y to the n plus z to the n for any integer value of n greater than 2. Interesting number theory proposition which Fermat claimed to have proved, but we didn't have his proof. And for 350 years, mathematicians failed to prove it. And then in 1993, not so long ago, Andrew Wiles at Princeton claimed to have proved it. And he was a very good mathematician, famous mathematician, not as famous as he is now, and he claimed to prove it. But in fact, there was a slight flaw in his proof, and the mathematical community, when they examined his proof, They found it and corrected it with his help, or he corrected it with their help. And finally, the community of mathematicians that work on this area agreed that he had proved Fermat's last theorem. Now, why is this important? Why do I bother telling you about this? Well, if you're a lone wolf mathematician and think you have proved Fermat's last theorem, you have to consider the disjunction. Either I have proved Fermat's last theorem, or I am going mad. And for 350 years, there were many great mathematicians that thought they'd proved Fermat's last theorem, and they hadn't. They were crazy. So you have to take that disjunct seriously. Only the formal concession and subsequent congratulations of your colleagues could or should put that anxiety to rest. If God tells you, you've got it, don't trust that. Don't trust that. Instead, you have to trust your mathematical colleagues. I don't trust Andrew Wiles. First of all, I can barely understand the mathematics. It's a very complicated proof. I trust the mathematical community, which vouched for him in 1995. That this is a social fact. But without that social fact, we would not know today whether Fermat's last theorem was proved or not. Why do I trust the mathematical community? Because arithmetic works. It's as simple as that. Now we want to talk about bootstrapping. It's a term in English that was originally meant to describe an impossible thing. Pick yourself up by your own bootstraps. You can't do that. But bootstrapping of various sorts, it's not magical. It's perfectly possible if you know what you're doing. And bootstrapping has worked in the past and can work again. And I'm going to give you an example. How do you draw a straight line? Well, you take a straight edge and a pencil, and where do you get a straight edge? Who made the first straight edge, and how straight was it? The ancient Greeks, the ancient Egyptians had wonderful straight lines. You can pull a string north as tight as you can get it. We've been working on straight edges ever since the pyramids were built. I found this lovely old picture of making a straight edge. This is a box straight edge, and when this picture was taken, this was about as good as you could do, self-proving and relatively insensitive to temperature change. That is a state-of-the-art straight edge of a few years ago. How straight is it? Well, let's magnify the edge. How straight is that? Well, that's 1,000,000 times magnification. The point is, now, today, we have developed tools so that we can measure straight edges to ever finer and finer and finer degrees of precision. And that's bootstrapping. It's not certain. Forget Descartes, forget God, but you can bet your life on it. It's that reliable. Today, thanks to bottom-up science and engineering, we have achieved amazingly precise measures of space, time, temperature, mass. We've decoded the human genome and many others, landed on the moon, explored the universe. We really are Homo sapiens, the apes that know a lot. And it's we who know it. And that's thanks to language, which allows us to teach, to compare notes and disagree and share our knowledge. We have developed wonderful tools for many things, including, of course, many wonderful tools. But I'm going to talk about an axe, an ancient tool, but it's still a wonderful tool because I want to draw a comparison between an axe and science. I found this picture recently of the cutting edge of an axe, magnified quite a lot. Now, this is a beautifully sharpened axe. You could hardly do any better, but in magnification, the cutting edge looks sort of like the Rocky Mountains or the Alps. It's very jagged. And it is populated, the cutting edge in every science is populated by people with agendas, big egos, emotions, passion. It's a free-for-all mess on the cutting edge in every field. The fury with which the defenders of scientific orthodoxy defend their doctrines against the heretics is probably unmatched in other arenas of human rhetorical combat. And these competitions for allegiance and, of course, funding are typically are designed to capture attention. And being well designed, they typically succeed. So the effect is that the cutting edge of any science draws attention away from the huge, uncontested background. It is the heft, the dull, solid weight of the rest of the axe behind the cutting edge. That is the source of science's power. If you just have a sharp edge, you can't do much work with it unless you have that solid background of accumulated results that everybody agrees. Now, that doesn't mean it's all true. There are items of scientific agreement that are very widespread that will turn out in the fullness of time to be overthrown. But without that agreement, without that not just agreement, but recognized mutual agreement, you know and I know that you know and you know that I know that you know, this fact undergirds the authority of science today. It's the dull metal weight of the rest of the axe that gives the edge its power. Philosophy, unlike the empirical sciences, has no accumulated weight behind it, aside from the science that has provoked and shaped it. This goes way back to Plato, Meno's paradox. Socrates, in philosophical discussion with his students, pointed out, if you know what you're looking for, then inquiry is unnecessary. And if you don't know what you're looking for, inquiry is impossible. This Meno's paradox has entertained and engrossed philosophers for several thousand years. And the solution turns out not to be God, but the power of respectful but also combative, competitive interaction with our fellow human beings, cogitamus. I'm going to compare philosophers at work to anthropologists. Imagine some anthropologists who are studying a Stone Age tribe, maybe in the Amazon or something, and they're patiently and sympathetically evoking the beliefs of their native informants. And they write this all down, and they try to write the maximally rational reconstruction of the creed the belief set of the people that they are studying. That's how anthropologists work. And the result is a codified folklore composed of good natural history. Stone Age hunter-gatherers know a lot about the fauna and flora of their land. Superstition, myth, it's all mixed together. Now, philosophers often engage in anthropology using their colleagues and themselves as their informants. I call this a prioristic anthropology. You get a few of your friends around. The rationally organized folklore of a small coterie of, for instance, Anglophone philosophers who've all read the same books. That, alas, is often the methodology of the philosopher, and the results are often not impressive, although done by very smart, very clever people devoting their lives to it. They're more likely to get more truth in their agreement than the Stone Age people, but only because they've been absorbing secondhand science all their lives. They've heard about quantum mechanics and evolution and all the rest of it, and that has informed their imaginations. What you can imagine depends on what you know. And as I like to say, the great foible of philosophy, but also in science, is when you mistake a failure of imagination for an insight into necessity. There are many cases of that. We philosophers, if we know the science, can help frame the question. That's why I'm here. Thank you very much for your attention.
Thank you. Thank you so much, Professor Dennett, for your talk. Let's open it up now to the audience for some questions. We'll keep you with us a little bit more if you may. So the session will be facilitated by Marwan Jawad, who is a postdoc scholar at the Institute for Advanced Studies, hosted by UM6P. He works with Raphaël Liogier. Welcome to you, Marwan. Please make your way to the stage. Let's give him a round of applause. And please get your questions ready, ladies and gentlemen. This is a unique opportunity for you to continue this conversation. Marwan, take it away.
Thank you so much, Manal. First, what a privilege and honor to share the stage with Professor Dennett in this beautiful campus, in this beautiful university. Thank you for reminding us that the sense of communitas and community is really important. And that's why this university has something really special in the international level, that we allow the individual genius to arise, but also there is the community to back it up and to having this kind of feedback loops as a community validation to put it in your words. Thank you so much for your presentation once again. It's thought-provoking. And I just want to add a poetic layer to this scientific and hard science. Assuming that we need scientific facts, scientific discoveries, but also we need the narrative to channel. And as a medium, we need engaging narratives. That's why we need poets. I'm not saying that. There are a lot of artistry out there. I'm thinking about the Red Poets Society, who said that we don't read and write poetry because it's cute. We read and write poetry because we are members of the human race. And the human race is filled with passion. Law, engineering, science, those are noble pursuits necessary to sustain life. But poetry, beauty, love, these are the things we stay alive for. Ursula Le Guin put it even more beautifully. Science describes accurately from the outside, but poetry describes accurately from the inside. Science explicates, but poetry implicates, and they both celebrate what they describe. So I think we need a storytelling that accompanies this scientific discoveries, and we need community. And I have few questions for you before I turn to the audience. First, as a community, what are the prerequisites to come together as humanity to address those existential challenges? We are talking about the climate change, we're talking about AI as an existential threat. So for you as a really known philosopher, how do you see these kind of challenges being addressed together?
Oh, thank you. And let me say, it is a great honor to be here. I think this program and this university, the more I learn, the more impressed I am with it. I think there's a great future here, and I am so proud to be invited to be a part of its inaugural period. Last night, I mentioned at dinner Anatole Rappaport's rules, which I think are the key to good communication in the sciences. Anatole Rappaport was a psychologist and social scientist who proposed 4 rules for how to debate an issue, how to criticize an opponent in any of the sciences or in philosophy. And by the sciences, I include history and politics, everywhere. And I taught these to my students. I actually gave them exercises requiring them to follow Rappaport's rules. So here are Rappaport's rules. 1, attempt to express your target's position so well, so clearly, so vividly, that your target says, thank you, I wish I'd thought of putting it that way. Now, if you can do that, you're in great shape. You can try. You may not succeed, but it's an excellent thing to try. And it is, of course, an antidote to the philosopher's overuse of the philosopher's favorite weapon, which is reductio ad absurdum, where you're nasty and mean and nitpicking when you talk about your opponent's view, and you're going out of your way to find the most embarrassing exposition of the idea you can muster. No, don't do that. Second rule, if your target has taught you anything, mention it. Say, you've persuaded me of this and this and this. Third, if you agree with your target on some matter where there's disagreement elsewhere in the relevant community, mention that. Only after you've done those 3 things should you say a word of criticism. And when you do, you have a very attentive audience in your target, because you've proved to your target that you understand his or her position, that you're smart enough to have learned something from him, and that you agree about something that some folks don't get. So remember Rappaport's rules and actually self-consciously attempt to honor them, to use them in your own work, and things will go a lot better.
Thank you so much. This is exactly it. You talked about the respect in the scientific while spreading those ideas. And there is a beautiful concept and the quote, the African quote, it's called Ubuntu. I am because you are. So we need the other. Even in the sociology realm, there is a sociologist called Charles Horton Cooley. He was in the American school. He said, I am not who I think I am not who you think I am who I think you think I am. So we need the other as a mirroring glass to know better. So thank you for reminding us all these insights. Now I turn to you, the audience. Please raise your hands if you have a question.
Thank you, Professor Dennett. I have a question about Descartes, because you said Descartes got it spectacularly wrong, because instead of saying, I think, therefore I am, he should have said, we think, therefore we are, or some such thing. And then you gave the example of Andrew Wiles and why you trust the community, not the guy. Well, personally, I always thought that the error of Descartes was that he was the last of the scholastics, like he was mixing God and reasoning and starting with himself, I think, therefore I am. At the same time, when Galileo was doing exactly the contrary, Galileo was looking at the facts. He has this thing that was invented in Holland. He was looking at the moon. He was looking at the satellite of Jupiter. And Galileo was actually looking at the world outside there. And then science began in earnest, because Galileo never said, I think, therefore I am. Galileo said, I see the moon, and there are mountains on the moon, contrary to the church orthodoxy. So, did Descartes made two errors, yours and mine?
Oh, he made more than two. And they were, I mean, more than two really big ones. I think you've put your finger on one of them. Now, first of all, let's remind ourselves, Descartes did a lot of good investigative science. His optics, his work on vision, to give one example, he was a real scientist, but he was a scientist malgré lui, in a sense. Because, as you say, he had this scholastic background, and he was an individualist in his approach, and that was, but I think his biggest mistake is in his third meditation, where he tries to prove the existence of God using the argument from design. And until Darwin came along and showed what was wrong, that was a pretty good argument. I have an article on that. It's my one scholarly article about the history of philosophy. It's called Descartes' Argument from Design. Descartes was very impressed with his own mind, and well he might be. And he thought, modestly, these ideas I have are too wonderful for me to have dreamt them up. I cannot really be their author. They fit together so beautifully. There must be a God that made them, an intelligent designer that made them. And he actually compared his ideas to machinery, the same way that Paley compared nature to a watch. So Descartes got close to Darwin. Darwin is the theorist whose inversion exposed Descartes' greatest error, I think.
Just thank you again for this very great talk. Just not to try to defend Descartes, but as a Frenchman. Yeah. No, what I want to say is first that when Descartes talked about doubt, it's really methodological doubt. It's really methodological doubt. So, in a way, when he will say, I think, therefore I am, I don't think, I know everybody, I mean, most people will say I'm wrong in what I'm saying, but I think he didn't care much about that, but except that it freed him to be able to doubt about everything else, and so to do science. So it was a way in his time to be able to doubt about everything, say, at least I don't doubt about that. And I think what he's actually doing with God is exactly the same thing. Don't forget that at that time, you can't say that God is like, as somebody else said, an unuseful hypothesis. You can't say that. So he said, look, everything I'm observing is so perfect, and he will put it like rational, that it must be created by God. Therefore, everything I'm doing, trying to unveil reality, is not blasphemy, so I can do whatever I want. I think it is, socially useful for him to behave this way in order to free his mind of any limits of what he will discover, and not the other way around. So in a way, I will say, in front of Darwin, he will not be ashamed, because it's not what was at stake for him. What was at stake for him is to free himself, to think freely according to the conditions that were the actual condition at that time.
Yeah, well, you're certainly right that it was a practical solution for him to base his whole theory on the existence of God. The church played a very powerful role, and some philosophers and historians have actually argued that Descartes was really playing to the Jesuits. He didn't really mean it except politically. And of course, we know that today, many scientists are extremely aware, and so they should be, of the political background of what they say. And if you've got a radical idea that you want to push, it helps if you can get some establishment support of one sort or another for your radical ideas. But remember, what I've said about Descartes' theory in Le Monde, first theory of everything, it's hard to imagine a theory that is as compelling, even today, in retrospect, as it was, but as wrong as it is. It's wrong about almost everything in physics and physiology. And he thought he had proven all of this from this one idea he had of God as a perfect being.
Question, please.
Okay, thanks. I think that's me. Over here.
Well, thank you for the talk, Prof. I think we can deduce that the transmission of science, I don't know if I should call it evolution now, from the Greek era. I want to be specific with mathematics.
I'm sorry, I have hearing aids. I'm having trouble hearing your words.
I said the transition of science, we can quantify it with two phases from the Greek era and the Middle Ages. I want to be specific about mathematics, the transmission or the evolution of this field. During the Greek era, we know that they conceptualize mathematics philosophically. They think about mathematics in a philosophical approach. Then the Middle Ages brought another dimension that made it more applicable. My question is that, do we have this ideology complementary in our modern world? Do we have, because the way we approach sciences now is more experimental approach, practical approach, compared to the philosophical approach of Socrates, for instance. So the Middle Ages have been able to use the algebra to bring forth solutions to our modern world. Are they complementary now, or which one is superior? Thank you.
Thank you. I think I understood your question. Mainly, it's the sound system that's making trouble, not your articulation. Mathematics is fantastic. It's wonderful. And for thousands of years, since Plato, since before Plato, thinkers have treated it as an ideal. This is the perfection of science. Start with arithmetic, start with geometry, start with Euclid. And this has led many people, not just philosophers, but in many sciences, to engage in what you might call the Euclidification of their field, whatever their topics are. They want to get theorems, they want to have axioms, they want to have proofs. And look at the results. You have amazing formal theories. Decision theory, game theory, logic, recursive function theory, number theory, on and on and on. Amazing intellectual edifices. And we know, the way we know about Weyl's proof of Fermat's last theorem, we know the soundness of a lot of this work. The extent of our knowledge is, in some regards, breathtaking. But we have to remember that these are models, and that they're all oversimplifications, and they're oversimplifications because that's the way to do science. I sometimes have to remind my colleagues in the humanities when I tell them that, yes, even poetry in the end is one of the fruits on the tree of life that Darwin explained. And they shudder at this and they don't want to believe this. And I say, wait a minute. You think evolution fruits of the tree of life?
Thank you so much. And I think this is so true, because if we needed only scientific facts, we would turn to the phone book, to the yellow phone books. It's full of facts, but it doesn't give us what the French calls the frisson, those goosebumps. And that's why we need meaning, and not only bread and water and air. We need something much deeper, otherwise it's full and open neurosis and despair. So what is the next question, please? There is a hand.
I have a question here. Thanks. So my name is Cathal Madigan. I work in a school in the university called the School of Collective Intelligence. And we have a department here studying the circumstances under which communities or groups can make better decisions than individuals. And you gave a beautiful illustration of this at the beginning of your talk with the proof of Fermat's theorem that wasn't accepted until the community decided that it was right. But a really interesting dynamic is between the cases where individuals can solve problems very well on their own and where the problem can be solved very well by the community interacting or deliberating together. And I think it's an open question in psychology, let's say, what the order should be. Does the community come first, or does the individual come first? Or are there some subjects for which you need the individual to do the work, or are there other subjects for which you need the community to do the work? And I'd just be really interested to hear your thoughts on that question.
Yes, that's a very important question to consider, and my thoughts are, I think, fairly obvious, but worth reminding us all of. Today we have papers published by CERN with hundreds of authors. No single author understands all of it. This is a collaborative effort of breathtaking size. And this is a fairly recent phenomenon, this idea of collaborative science on a huge scale. Let me just make a point which has a sad side to it. Now that women are playing such an important role of science, they are coming into their own, finally, at a time when the very model of the individual genius scientist is beginning to pale, and group efforts are taking over, where nobody gets all the credit. So, are we going to see a Newton, a Darwin, a Descartes among the women in science today, or are the best of them all going to have to be satisfied with the role of being the chief proponent, the chief innovator of a large community of people working on the same issue? I think you all know cases that are now up for grabs and a little bit vexed, whether it's say CRISPR or that's perhaps the best example. My friend Nicholas Humphrey once responded to an article in the British press that said that Newton was the Shakespeare of science. And he said, no, Newton and Shakespeare are completely different. If Shakespeare hadn't existed, we wouldn't have Romeo and Juliet and Hamlet and all the other plays. But if Newton hadn't existed, somebody else would have got there. The Newtonian physics would have been established sooner or later. There's a profound difference between the creative, one-of-a-kind path of a poet or an artist, and even the most brilliant work by a scientist. And I think that's a point to ponder and to take very seriously. Priority disputes in science have a special role to play, but priority disputes in literature are sort of beside the point, unless it's a case of, plagiarism.
Thank you so much. And this is humbling, actually, to think of science as a creative power that comes through us and not from us. And though it is with us, it belongs not to us, to paraphrase Khalil Gibran. So it's humbling in a way. And I saw some hands raised out there.
Hello.
I don't know the priority.
Yeah, thanks. Thank you, Prof. Dennett, for your wonderful talk. My name is Salim Lehlou. I'm an AI researcher in Montreal, and I'm really interested in questions about consciousness and free will, which you have worked on a lot. Media and online bios of you portray you as a vocal atheist, and I'm wondering if you had some thoughts on how countries like Morocco, where many so-called scientists are even allergic to the word Darwin, how such countries can have a pathway towards secularism, whether that's a good thing or not, and whether there are alternatives to the savage neoliberalism that's in the West.
I'm sorry.
Yes.
I'm not. Can you tell me what my hearing is?
Yes. Can you repeat it and slowly, if you can? Because.
So I'll repeat just the part of the question. So media portrays you as a vocal atheist, and I'm wondering whether you had some thoughts on how countries like Morocco can pave their way towards more secularism, and whether that's a good thing, and whether there are alternatives to savage neoliberalism or bellicism that we see today. And also another question about free will. Do you see any societal benefits in discussing these questions more openly?
Yeah.
Thanks a lot.
Let me take the free will question.
Okay.
right now there's a lot of debate going on about free will, and I think much of it is misguided because many scientists have been misled by philosophers into thinking that free will isn't real free will unless it's truly indeterministic, and that's just a mistake. It's a mistake of inflation. Free will and determinism are perfectly compatible. Free will in the sense that matters. The sense of responsibility that you mentioned. When I sign a contract, sometimes it has to be notarized, and the notary public says before I sign it, "Are you signing this of your own free will?" And I say, yes, I am. She's not asking me a metaphysical question. She's asking me if I am sane and not under duress and able to be moved by reasons. And the answer is yes, I am. Free will is an accomplishment, not a metaphysical endowment. We grow into free will. Our small children don't have free will. They have wills that are in a sense free, but they're not responsible. You grow into free will as you mature, and most of us meet the test just fine. I'm sure everybody in this room has free will.
Thank you.
We still have the time for 2 questions or 3. Yeah.
Yes, please. Thank you for your inspiring talk. You mentioned many things about scientific community, which is a pragmatistic point of view, and I was wondering how you connect this standpoint with your well-known hypothesis about naturalization of mind, as you explained all these things in your books, Brainstorms and Consciousness Explained. Thank you.
This is a great time to be alive working on the mind. The advances coming in neuroscience, cognitive science, artificial intelligence are just breathtakingly valuable because for the first time we are beginning to see glimmers about how to answer what I call the hard question. In the past, most theories of consciousness worried about how things became conscious. How does Descartes, how does the light strike the retina and then move through the optic nerve, and then he said to the pineal gland, and then to the mind, the conscious mind. The last part of it was, of course, staggeringly wrong, but the first part was pretty good, the optics and so forth. But they stopped when the content, the information, got to consciousness. Then it was problem solved. No, you haven't begun a theory of consciousness until you ask and answer the question, and then what happens? How does the conscious mind work? How do the words that are coming out of my mouth right now, how do I do that? How do you do that? How are you able to utilize, reflect upon, be moved by, be angered by, be amused by the sounds that your brain is processing? If you stop at consciousness, you only have half a theory. And it's the second half of the theory, and then what happens, that we now are beginning to make progress on, and it's very exciting times.
Thank you so much. That's another reminder that language is not only descriptive to describe what's happening, it's also generative. As we speak, therefore, we become. And thank you once again for reminding us that we live in a great era, despite don't trust the media. The media follows the quote that if it bleeds, it leads. We have the amygdala, they know that. So we are living in a great time. I refer to the works of Pinker. The probability for a man being killed under the hands of another man has never been lower. So we live in a peaceful, great era, and that's your opportunity to take it. And as humanity, we have achieved wonders, miracles. As Terence McKenna said it, we take in matter of low organization, we put it through the minds of, through the filters of our mind, and we extrude space shuttles and iPhones. So that's us. And that's our language that was a singularity in itself. From the early hominids to now, language reveals to the mind what the mind thinks about itself. And in this feedback loop, this ontological designing, we emerge. So that's an aha moment that I wanted to share with you. So can we take one or two last questions? There is a question there.
Yeah. Assalamu alaikum jami'an. Thank you so much, Dr. Dennett. The intervention is great, and I really like the discussion. And I want to join Dr. Raphael when he talked about Descartes. And I really don't want to defend Descartes neither, but what I want to say is just every scientist is already a human being, and every human being is having an agreement with the society. And this agreement, he's trying to protect this agreement, and by the end, protecting himself. And I liked when we talked about transition, and in fact, the transition maybe we need, and we are talking about, is the transition between the individual agreement to the community agreement. And one word I was waiting to hear today so that we can make this transition possible is the word just transition. And basically, this transition between the individual agreement to the community agreement can never happen if it is not a just agreement. So my question is, and I want to give the example of the earthquake that happened recently in Morocco. So we were able, under this crisis, to shift quickly from the individual agreement to the community agreement and behave. So my question to you, Dr. Dennett, what do we need exactly to move from individual agreements to community agreements? Do we really need crisis to make it happen? How can we make this transition a just one? And work with collaborative knowledge models to come up with policy ideas for the end users and the end decision makers. Over, thank you so much.
Well, how do you do it? I think you probably know better than I do. And so I'm going to trust you and your colleagues and your students to put your heads together and figure out for yourselves the best way to proceed to create this wonderful community that you've started.
Thank you so much, and thank you for your question. Edgar Morin, who was here a few days ago, he said that the crisis, he wrote a book called Pour une chrysologie, and the word crisis, the Greek root, it means crisis, that means when all the symptoms are clear. To say if it's a disease, if it's a COVID or something. And so meaning that even the concepts are in transition, and that's why we need to recontextualize the discussion. So to wrap it up, thank you so much. Thank you, Dr. and Professor Dennett, for reminding us that we're all in it together. We need radical openness, we need serendipity, we need inspiration, we need awe, and we need open minds, as we say, the minds are like parachutes, they only function when they're open. So thank you so much. Thank you once again for being with us. It's really a thrill. And thank you, everybody.
And thank you, Marwan. Thank you so much. Let's give it up for Marwan.
Thank you.
Thank you, Professor Dennett. Such a privilege. Ladies and gentlemen, I just want you all to take just a moment and take in the fact that you've listened to a live conversation with Professor Daniel Dennett. These are the kind of conversations we like to have in big universities, spark ideas, exchange ideas, and make it all happen. Put our heads together, as it has been mentioned. Ladies and gentlemen, this concludes our morning session. We will meet again after lunch at 2 p.m. sharp. We've been perfectly on time up until now, so I'll please kindly invite you to join me back in and call on your friends at 2 p.m. sharp. We're just getting started. We've had amazing conversations happening this afternoon, amongst them Mike Zaborodko. Have a wonderful lunch, connect, visit the booth. The booths are available for you, and we'll meet back here at 2 p.m. sharp. Thank you.